Okay, in this video, I go over example 3, which is how to model a priority system. Priority systems are when entities arrive, either people or parts, and the next one process is not necessarily the next one that arrived. That particular process is called FIFO, or first in, first out. But sometimes the first in isn't and shouldn't be the first one processed. Think of an emergency room. Think of situations where the high priority item may need to jump over the existing queue to the front of the line. And so that's a situation we have. Example 3, we have a machine shop that fixes things. It does tool repairs. And some of these jobs are low priority or priority 1, some are 2, and some are 3. And these are the arrival rates. In repairs per hour, 2, 2, and 1. So how I'm going to start this is I'm going to create 3 different arrivals. Scoot them down a little bit. Scoot that over. That's what I'll do. There. My 3 different arrivals. In this first one, the arrival rate is 2 per hour, so my time between arrivals is 1 over the arrival rate. Same thing on the second one, 1 over the arrival rate. And the third one is 1 over 1, or just 1, but I'll put it that way. And I'll give each of them their own queue. So these queues are places where these arrivals are waiting. Even if this was an emergency room and they were all waiting in the same place, we use this abstract modeling strategy so we can keep the different priorities separated. And as long as we can do that in real life, then it's okay to model that, even though they may all be waiting in the same location. And then I want to model an activity, which is a repair person, and we have a total of 6 repair people. And the service time is also exponential. And we can, it says their service rate is 1 repair per hour, so we put that in the denominator, but so it's just 1 hour. On average, it's 1 hour. And, whoops. And they can grab from the high priority, and then if there's nothing in the high priority, they can go to the second priority, and then they can go to the third priority. And when they're finished, they leave the system. But I want to be able to tease out the stats or metrics based on which priority. So I want the high priority parts that originate here, I want them to leave through there. Like that. So before we add the rest of the repair people, let's talk about what we've got. If I look at this repair person, and let's just rename him, let's call him repair 1. If I look at that person, how do I grab and pull information into the system, which is routing in? And right now, the default strategy is that it's using a priority discipline, and all that means is that it grabs from this queue if there's anything there, and then it goes to this one, and then it goes to this one. Now I could move that one up if I wanted that to be the most priority, but I don't. That's the third priority, so I'm going to move it back down. So it'll pull from this one as long as there's something in there, only goes to this one if this one is empty, and then it'll only grab from this one if the 2 above it are empty. So that's perfect. That's exactly what we want. But what about routing out? How do I route out to these checkouts so that the priority ones that go this way wind up here? Well, the routing out discipline, circulate means that it is like marching. It goes to this one, and then this one, and this one, and the fourth one goes back, and we certainly don't want that. Uniform is equally likely. We don't want that because these may not be equally likely. Percent is a generalization of uniform where I can dial in. We don't want that. So you would think priority, that would be the one we would want. But that's not the one we want. But let's talk about what priority does on the routing out. If you route out based on priority, that means that this is the preferred route. and if that one is ever blocked, then you would go to this one, and then if the top two are blocked, then you would go to this. But these checkouts are never blocked because all they do is allow entities or work items to leave the system. They're never blocked. So if you would model with a priority, then every item would wind up going there. We clearly don't want that. So what we're going to wind up using is a label. Now a label is a trait of a work item. It's like the part number. So if I were modeling parts moving around the system and I had a part number for each of those parts, a unique tracking ID for those parts, those would be label values. And I can have many different labels. Think about just a label that something is shipped. You've got a name, an address, a town, a state, a zip code. All of these are different labels that we could have. So how do we create labels? And you can do it in different places. I could do it right here. In fact, I think I will. I'm going to pick label, and it's going to prompt me, all right, which label do you want to use? Well, I haven't created any yet. So I'm going to create labels, and I'm only going to create one, and I'm going to call it, I'm going to always start with I'll call it label, and then I'll use an underscore. You can name this whatever you want. I like to put label at the beginning, so then when I see a list of all my objects, my labels are all together. And I'm going to call this priority level. So there I've created a label. And if that label value, if that priority level value is 1, it goes there. If it's 2, it goes there. It's 3. So how do I set that value of label priority level? Well, we're going to do that when they're created. We're going to do that over here. So this one is my priority level 1s, 2s, and 3s. So I'm going to go into this one, and I'm going to go under Actions, and I'm going to look at this. I want to add a label to change. I've already created it, so label, priority level, and I'm going to set it to, and then of course the default's 1, and I'm going to take that. I'm going to do that for the second one. Actions, add a label to change. There's only one label, but its value now I'm going to set to 2 because it's the middle one. This one is 2, and now this one I'll set to 3. Actions, add a label, set to 3. And by the way, this doesn't have to be hard-coded. It could be variable. We can have it grab set a label value variable. Think about if you wanted to say how long, if you wanted to assign a label to something that was stochastic or uncertain, but you know it was in some range. We could do that as well. We're just not for this example. So now that we've created that label, and I would run this, it's going to route based on this one, but when it routes out, remember that value can either be 1, 2, or 3. So it's going to take that value on. I mean, it's set is how it routes out. Now, I'm going to duplicate this. I've got a total of 6. I'm going to duplicate it 5 times. I'm going to put them close together. All right, there's my 6 repair people. And I'm going to run it really slow so we can kind of track through. That's way too fast. Stop and rewind and do it again. So let's look at this one went there, and it should go here because it came from the bottom one. So this one should, there you go. Now this one came from there, so it should go up here. This one, 5, when it's finished, it ought to go to the top one because that's where it came from. Of course, a lot of things are happening, so eventually that one is going to go, let's say that. There you go. It finally took off. So I think it's working right. And so now I can set my metrics that I'm interested in calculating. And it's asking for system utilization. So I'm going to grab all of these, click on one of them, go to results, and get my working percentage. And so it's going to grab my working percentage for all of those. And it's going to ask me, you want to change all of them? Yes. Then the average time that a particular tool is in the system. Well, that is all of these. I'm going to grab one of them. So let me do that again. I highlight all of them. I grab one of them. It doesn't make any difference which one. Go to results and then right click on the average time in system. And the last one is the average number of tools waiting for repair for each priority level. And that's the queues, the average number waiting. Grab all of these, go to results. It's the number waiting, so I'm going to click on this. And now, and yes, it wants me to change all of them. I'll go run a trial. And there's your output. You can see that the system utilization is about 83%. You can see that the priority ones, time in system is a little over an hour, but the priority 3, which are lower priority, are in the system longer. Same way the lines are longer for the lower priority. And there's other reasons that could drive that, but what the reason you would expect to see this is that the high priority don't wait very long, or the lines aren't very long. They go through the system quicker because they're high priority. Okay, that's example 3. Thanks.